Welcome to the GPT saga in the LLM era, where we trace how model design, market forces, and enterprise adoption have evolved together. This presentation walks through architectures, scaling dynamics, integration strategies, and likely futures, and the cover graphic hints at layered systems and growth curves that we'll unpack slide by slide to build a cohesive picture. GPT-2 showed the surprising power of scale. With about 1.5 billion parameters trained on roughly 40 gigabytes of web text, it produced fluent text and rudimentary zero-shot reasoning, revealing that bigger data and compute unlock general-purpose capabilities. That breakthrough also sparked policy debates about staged releases, emergent toxicity risks, and the need for a responsible disclosure framework. GPT-3 marked a paradigm shift through few-shot learning. At roughly 175 billion parameters and prompt-only adaptation, models began adapting to new tasks without gradient updates, producing emergent abilities like code generation, translation, and dialogue. The result was a market shakeup. API waitlists exploded, and a new scale plus context paradigm firmly replaced traditional fine-tuning in many use cases. Alignment evolved into a two-stage practice to steer LLMs towards safer, more useful behavior. First came curated fine-tuning to align model responses and reduce harmful hallucinations, and then reinforcement learning from human feedback to refine preferences and safety through iterative feedback loops, producing models that score higher on helpfulness while setting a new standard for safer generative systems. ChatGPT acted as a catalyst for mass LLM adoption by combining GPT 3.5 capabilities with conversational RLHF, enabling coherent dialogue, code debugging, and creative writing in an accessible chat interface. Its unprecedented adoption velocity, reaching tens of millions of users in weeks, accelerated enterprise roadmaps, prompted rapid implementation projects, and triggered competitive launches of rival chatbots and foundation models. GPT-4 extended the frontier with multimodal inputs and much longer context, enabling image and text understanding, human-level benchmark scores, and richer use cases like document analysis, accessibility improvements, and visual reasoning. Scaling trajectories continued upward, while innovations like sparse attention, improved safety filters, and more scalable oversight made broader multimodal applications practical and safer to deploy. Scaling laws provide an empirical foundation. Test loss tends to fall predictably as compute, dataset size, and parameter counts increase, following a power law. The GPT series tracked this trajectory, which in turn guided billion-dollar training budgets, hardware planning, and predictive models that help forecast performance gains and optimize resource allocation across training and deployment pipelines. Beyond smooth loss curves, phase transitions describe qualitative leaps in model ability that emerge past critical thresholds, producing capabilities like chain-of-thought reasoning, stronger instruction following, and advanced code completion. These emergent jumps require anticipating novel failure modes, prioritizing safety resources and red teaming, and designing evaluation suites that capture abrupt capability changes beyond standard metrics. The OpenAI commercial API helped democratize access and catalyze startup growth by exposing powerful endpoints for copywriting, code generation, and customer support. Usage-based pricing lowered barriers to entry, accelerating product-market fit for many teams, while prompting enterprises to rethink strategy from in-house model builds toward fine-tuning and simple prompt integrations that scale quickly. Open-weight LLM families, like Meta's Llama, Eleuther's Pythia, and Mosaic's MPT, expanded the ecosystem by offering permissive licenses, research transparency, and private deployment options. This open-weight movement fuels regional adaptation, accelerates research reproducibility, challenges proprietary incumbents, and broadens global access to powerful generative AI capabilities. A strategic shift toward multimodal, agentic systems appears across the GPT series, with examples like GPT-4o, Omni, and native audio enabling real-time conversation. These systems reason across steps, integrate external tools, and generate action-oriented answers, pointing toward future trajectories focused on enhanced problem-solving, tool use, and practical real-world applications. The next chapter aims for trillion-parameter models, deeper reasoning modules, and stronger alignment to enable reliable scientific discovery and safe autonomy, but faces a data wall, compute efficiency limits, safety governance needs, and societal readiness concerns. Navigating these technical and ethical challenges will define whether large-scale language modeling delivers advanced, reliable, and beneficial AI systems.